In this lesson, we will be reviewing linear functions, and we're going to start with a review of slope. So what exactly is slope? You could write down here in our notes that slope is the steepness of a line. It's also known as the rate of change. And technically, algebraically speaking, it's the ratio between the change in x and the change in y. And we know this better as the formula. So the ratio between the change in y and the change in x. But really, that's our formula, m equals y2 minus y1 over x2 minus x1. Now, what exactly do we get out of slope? Well, first of all, from a graphing perspective, we have 4 different types of slope. We have positive, negative, zero, and no slope, or undefined slope. Positive slope, you might see the equation graphed as increasing from left to right. An example of this might be y equals 3x plus 5. Negative, just going the opposite way, so it's decreasing from left to right. An example would be same thing, but negative 3x plus 5. Zero slope, so zero and undefined are going to be opposites, just like positive and negative. Zero is a flat line or a horizontal. And that is the equation, something like y equals 5. Undefined then would be the vertical line, and that's where we switch variables and say x equals, for example, 5. Now, the other thing that we have to review and what we'll be using the most from this particular lesson is the concept of parallel and perpendicular. So with parallel lines, you may recall that parallel lines have the same slope. So if one equation is y equals 3x plus 5, then a parallel equation might be y equals 3x plus 7 or minus 2, whatever you want to call it. Perpendicular then the relationship between the slopes here is that they are opposite reciprocals. And what exactly does that mean? Well, that means if one equation is, again, let's just say y equals 3x plus 5, we've used that a couple times now, then the other one would be y equals negative, and then flip it 1/3 x plus anything. We'll keep the plus 7 the same. Now, what does that mean as far as ways to write linear functions? So let's review some of the more common ways to write linear functions. The first one, we saw it in all the previous examples, is slope-intercept form. And that is just generically y equals mx plus b, where xy is somewhere on the line, a point on the line. And then m is slope, and 0, b is the y-intercept. Another form of writing linear equations is point slope form. And that is the equation y minus y1 equals m times the quantity x minus x1. Now again, in this case, x1, y1 is a point on the line, and m is still slope. And if you look at this, if we take the x minus x1 over here and divide it over, it's literally the slope formula. So this, the reason why it's called point slope is because it's literally the slope formula, but we solve for y minus y1, which in our slope formula, that's really y2, and then the x would be x2. But that's where that point slope equation comes from. The last one is standard form, which is also known as general form. And that's the one that's ax plus by equals c. The thing to get out of this, because we don't see it directly as we do in the other two forms, is that our slope is equal to the opposite of a over b. So we just take a and b, divide them, and then we take the opposite of it. Again, things to keep in mind for this form, xy lies on the line, is a point on the line. And then a couple rules that we have to take into account for standard form. First of all, the values a, b, and c have to be integers, which means there's no fractions or decimals. So if we're writing into standard form, we have to make sure to get rid of those. And then the last thing we have to keep in mind is that the a needs to be greater than 0 to be in technical standard form. So that means we can't have a leading negative. So if that happens, you'll just multiply everything by -1, and that'll take care of it. Now, to look at a couple examples of what we're going to do with this. So our first example of writing linear equations is a word problem. It says here that a teacher has given a test in which the highest grade was an 85 and the lowest was a 40. We are to determine the linear function that can be used to distribute the test scores so that a grade of a 40 becomes a 60 and an 85 becomes 100. We are then tasked with expressing our answer in slope-intercept form. So that's y equals mx plus b is our final answer format, which means if they gave us m and or b, we have something automatically. If not, we're going to have to solve for them. And if we look here, we have 4 values, 40, 60, 85, 100. And if we think a little bit about what those numbers mean here, think of 40 as the input that's becoming, after we put it in the function, the output of 60. Same thing, 85 is the input that goes into the function and becomes the output 100. So what they gave us are 2 ordered pairs, 40, 60, and 85, 100. Now, neither of those are the y-intercept, nor are they the slope. So we'll start. When we have 2 ordered pairs, we can find y2 minus y1 all over x2 minus x1. And if you know where to go from here, feel free to pause the video and just come back and check your answer. Just keep in mind that we are going to get fractions on this one, and I would prefer that your answer be in fraction format at the end versus approximating the decimals that you would get in place. So if we simplify the slope here, we're going to have 40 over 45 or 8 over 9. Now to find b, so that we get to y equals mx plus b, I'm actually going to use that point slope form, which means we're going to do y minus y1 equal to the slope times x minus x1. And then in this case, I'll distribute first, keeping in fraction format. So that becomes 320 over 9. And then all we have to do is add over the 60, convert that to ninths first, and our final answer should be y equals 8 ninths x plus 220 over 9. Now, our next two examples are asking us to state the general form of an equation given a line that was parallel on the left and perpendicular on the right. So we'll work with both of those concepts. So first and foremost, for the one on the left, we're writing the equation of the line that's parallel to 5x minus 2y equals 3, given the point -3 on the new line. So first and foremost, remember from the front of the packet that parallel slopes are the same. So I want to identify the slope, and then we'll reuse that to find the new line. So slope from general format is the opposite of A over B. So in this case, it's the opposite of 5 over, in this case, -2. So just positive 5 halves. Then, simply at this point, all we need to do is be able to find the C value. So I know that if the slope is the same, then actually we could go straight to 5x minus 2y equals C, right? But again, we don't have C, so what I can do from this point is just plug in the ordered pair. So we would do 5 times 2 plus -2 times -3, and simply solve that for C. So we'll have 10, in this case, plus 6. So C should equal 16. So 5x minus 2y equals 16 is going to be parallel to 5x minus 2y equals 3. Now, if we kind of use that same concept for the other one, since we're asked to do the same thing, but now from perpendicular, again, I'll start by finding the slope. In this case, it's going to be different. So we'll do opposite of 5 over -2, which is 5 halves. But the slope of the perpendicular, remember from the front, is the opposite reciprocal. So we're going to make that negative and flip the fraction 2/5. Now, how does that look in standard form? Well, remember that the slope in standard form is the opposite of A over B. So the opposite of A would be 2 times x plus opposite of A over B, in this case B is 5, equals to our standard form C value that we again have to solve for. So let's just double check that line and make sure we understand what just happened. So if I take the slope from here just to check it, we know it should equal -2/5. Slope from standard form is opposite of A over B, and there we have it. That does get us -2/5. So it gets a little weird there with the negative. And then in this case, we can do the same steps that we did on the last one. We'll take 2 times 2, so our x value of our ordered pair, and 5 times -3. And again, just simplify in this case to solve for C. So 4 plus -15. And in that case, we're going to get -11. So a line that is perpendicular to 5x minus 2y equals 3 would be 2x plus 5y equals -11.